aim of this training is to empower us, all of us, with a better understanding of the industrial mindset, of industrial development processes, and how to start conversations with companies. In today's workshop, first we will listen to the industrial point of view, and then later we will proceed with researchers and TTO's point of view. In the final part, we will answer your questions that you will post, and then also discuss the topics that you have raised during your registration, covering how to best contact companies, managing expectations both from researchers and companies, then motivation for cooperation from both sides, and also topics related to IP and NDA and others. You can place your questions via chat. We will follow them and answer them, ask them and answer them accordingly till the latest till the end. But before we start, I have two small questions for you, and I would kindly like to ask you if you could answer the first and the second question. The first one is being just for us to know how experienced perhaps you are already in cooperation with industrial partners. Do you cooperate already? You would like to, you don't cooperate yet. And if you're not interested, but I think the last one, it will not be so presented because I think this is why you are here. And the second question is, do you find the cooperation easy or not? So I will leave a little bit more time to answer the questions. So it's about 50, more than 50 of you replied. Okay. So just a little bit more. So 5, 4, 3, 2, 1. So 88% of you have replied, and then the final results are that most of you are already collaborating, and perhaps you would also like to cooperate. And when it comes to, do you find the cooperation easy? Only one has replied, yes, definitely. We would like to hear about your experiences afterwards. But for the majority, it is hard or sometimes easy. And some of you don't have previous experiences, and that is just okay. So we will try to present why and how to start collaborate with companies. So thank you very much for now. Now we shall start with the presentation. Our first presentation from the how to collaborate and why with universities from the industry side. So Mr. Janez Richteršič, we are very welcome. Janez is head of R&D at the company Domel Group, and he is very familiar with both spheres, the research and also the industry. Namely, after graduating in mechanical engineering, in 2002, he got his first job at the Faculty of Mechanical Engineering at our university as an assistant, and later as a young researcher at the company Domel. At Domel, he worked in the fields of suction unit development and fuel cells, and in 2009, he took over the management of mechanical development. And in the same year, he also obtained his PhD at the Faculty of Mechanical Engineering at our university again. In 2017, he completed his MBA studies at the Faculty of Economics, and in 2018, he became the head of R&D at the Domel Group. In his work, he cooperated with the development departments of many international companies, universities, and institutes. Janez, the stage is yours.
Thank you, Simona, and thank you also for the invitation that I can present our company and perhaps also to get some feedback where we can even improve to collaborate even better, or at least to be more understandable to you how to cooperate with us. I will take over now the screen. Do you see the screen?
Not yet. Now it started to show. And just take it to full screen.
Yeah. Is it?
Not yet.
You should see it.
It's not yet, but it is okay if you proceed that way.
Just to check. Somebody says that can see it, so I hope eventually all will see it. Yeah. So first of all, I should introduce also the company. I'm coming from company Domel. This is I would say middle-sized company. You will see onwards, and perhaps first few slides will be dedicated to the company so that you will see our background, and then I will come to how we work, how we deal with projects, and how we cooperate with external partners. And in the end, we can also see the results of such cooperation. So first, some background of the company. We were established in 1946. Actually, the company was established as a cooperative.
Excuse me, Hannes, we don't see the next slide. So it's,
because you don't have it in presentation mode.
I do have it.
No, because we see the slides in the left side.
The presentation mode is probably not the screen that you shared.
Okay.
I suggest you go out of the presentation mode and just scroll down without the presentation mode. That would probably solve the problem.
Just a moment. I will try.
We have tried before. It functioned. Everything was working fine. So now we can just adjust.
Sure. What about now? You see the screen?
Yes, we see the screen, and just try to move to the next slide so we know that everything is working.
And you see now also the next slide, or you don't?
No, still the first one.
Okay, then now you see the second slide. I will.
Yes, we do. Yes, we do.
Okay, I will be out of presentation mode, and Okay. So this is the site of our headquarters. So as mentioned, we were established in 1946 by 16, I would say today, entrepreneurs, because they actually started as a cooperative and they invested their own funds. But later on, it got a part of a bigger group, Group Iskra. This was from 60s onwards, and in 19s, when Yugoslavia separated, Slovenia separated from Yugoslavia, the company again became a self-standing company, and from that time onwards, we are called Domel. Nowadays, we are operating in 6 production locations. 4 of them are in Slovenia and 2 outside, 1 in Serbia and 1 in China. And on 4 locations, we have R&D departments. Altogether, we are 1,500 employees. And last year, we finished the year with 270 million euros of turnover. And yeah, to describe what we do, our core business are electric motors, for a variety of applications. And the strongest pillar are professional and home appliances. So for example, vacuum cleaner motors, mixers, blenders, kitchen robots, gardening equipment such as lawn mowers, leaf blowers, or chainsaws. So everyday applications that you use. Then industrial pillar, here we produce tools, also components for the tools. Then for construction, motors for heat and ventilation, and also for extraction of dangerous fumes, printing industry, fuel cell industry, and so on. The smallest pillar is laboratory equipment. Here you will find us in labs when they do analysis, for example, in centrifuges or shakers, then different sorts of environmental chambers, devices where they mill, for example, bones in fine dust to make DNA analysis and equipment like that. And a very strong pillar, it's also automotive. Here you mainly find us in e-mobility, different sub-systems, not the main traction drive, but oil pumps, water pumps, energy generators. Also on micro-mobility, for example, downhill bikes, then scooters, and also lightweight components for the automotive. So that you know what kind of products we produce. Perhaps on next slide you can see some of the customers you may know. We have a big variety of customers from all mentioned fields: automotive, gardening, household, construction, medicine. So altogether we have more than, I would say, 500 clients. These are probably 30 to 40 biggest one. And yeah, our markets are mainly European markets, with Germany as the biggest. Then yeah, Romania, also connected to German companies working in Romania. China, this is connected to our China plant. In recent years also North American markets are growing. Yeah, and also Far East markets such as Japan, Korea, also India. These are also growing markets in the recent years. So how do we produce all this? We are, as it was mentioned on one of the slides, we are quite vertically integrated company. So this means that we actually design our products, we produce tools, we design the assembly lines, and in most of the cases we do produce also the products that we designed. To be able to do this, we are having a matrix organization of our R&D, which is divided to central R&D. There we have different offices, departments, where we do also sometimes also basic research, or in between basic and applicative research. Here are experts employed mainly for numerical simulations, for experimental tests, for analysis of materials. On the other hand, we have then applicative developments, which are our connection to business units. So every business unit has its own applicative development, and yeah, we share the equipment, we share the experts between the business units. And I think also in similar manner, we cooperate also with external partners, faculties, institutes, laboratories. We are all together around 130 plus, working just on the development of products. Then a similar number would be colleagues that would work on technology side. So we do, as mentioned, we do set up our technologies internally. We do design of lines with automatization, with robots and everything. Have our own, as mentioned, tool shop, but this is different than prototype workshop where we produce prototypes. And there are also other laboratories, departments needed to make a successful development of product. This is also quality, marketing, procurement, logistics, all those knowledges you need to involve that you finally get a competitive product on the market. So it's, I would say it's really a huge number of expertise that you need, that finally when initial idea reaches the end market and that it's competitive on the market. Now, this is probably also a slight answer to question, how do you contact the company? You can contact the company through all such different windows that we have to outside. For example, from if you are, let's say, as I was a member of faculty of mechanical engineering, most of professors and students there can contact me via personal knowledge. It's not necessary to go to, I don't know, our CEO. And the same is with other fields of knowledge. For example, you can contact through personal knowledge with the person, or via internet. This is also possible. Then on next slide, I would like to show how we do design, or how we start with the design of new products. For example, here we have one chart, which I would say it's theoretical chart, but it's very true, for at least for our company, that most of the development, it's iterative development on the products that are our core business. So this we call Horizon 1 of innovation. Here you can see also the curves of life cycle of certain product portfolio. And you can see that initially we have, let's say, quite horizontal curve where the cells are not being started yet. And then through the lifetime, we do several iterations. So here we do iterative development. And here I would say that cooperation with external partner, it's more or less possible if this external partner, it's very well known, very familiar with this product portfolio. And this way we can cooperate quickly and efficiently. And it's sometimes it's, I would say, as mentioned, iterative design. Sometimes you need to do some radical innovation. For example, usually this happens when you transfer from one product portfolio to the next generation of the same product portfolio. Radical usually means that you changed something significantly. For example, that you have the same performance with, I don't know, 30% less material, or with much, I don't know, cheaper technology or more productive technology. And then you are on the next generation of products. after a while this becomes uncompetitive and you switch to a next. But sometimes you need to do also disruptive change. So it means a significant change. For example, here it's one such example. It's a significant change, and we know it will make an end to the previous technologies that we use, but it usually takes a lot of time that this new technologies it's implemented in all our customer products, and also that end customers get used to this new technology. So this I would say it's the most beneficial also for you. If you cooperate with some bigger companies, then you can survive this period that it's needed that the market accept some radical change. Majority of products is like this, that they need time. Only few products is that they are quickly accepted by the market. This is a really small percentage. Okay, then the next level of innovation, I would say Horizon 2. This is how we spread our portfolio of products from initial core business, I would say, to the neighboring fields. The reason why I'm saying neighboring fields is because we have the equipment, we have the knowledge. Perhaps we can bring something from our existing business to the new business, and which makes us more competitive on that field. So this is, I would say, organic growth of majority of companies. And yeah, it's a type of growth that we were heavily practicing for the last, I would say, 20 years. It enabled us to grow, I would say, in average around 10% per year. But it's, as mentioned, it's connected somehow to existing knowledge, somehow to existing technologies. It's rarely that there is something completely new. For the complete new innovations, we call it this Horizon 3 level of innovation. Those innovations are usually not connected to existing technologies, to existing knowledge, or even not to existing markets and I would say chain of values. This is relatively new for us as well. We started with this program of innovation, I would say 3 years ago. We established Open Innovation Office, where students, mostly students, are working on their new ideas. Our aim is to develop new products with higher added value for the incoming period of, let's say, in our lives. And yeah, here I must say that here we can meet with also with lean way of working. I will show this on next slide. And sometimes it's good if this is separated, for example, that it's happening on the university or in some other facilities, not directly in existing R&D departments. But then you lose also some vital informations that they are already available at the existing R&D departments. So here in this area, I think we are also somehow learning and growing a new way of working, collaborating with universities, with academia, institutes, and so on. But as you can see on this picture on the right side, usually there's a percentage of resources given to those different horizons are written here, 70, 20, 10. in our case, I would say it's more on this second horizon. I would say more than 50% of our resources are given to this second horizon. And then I would say 40 perhaps, or even 45 to first horizon, and only 5 perhaps to the third horizon. And if I go to the next slide, for example, that you are this innovative startup, for example, and you probably do it in a lean manner as it's shown on the picture on the left side. Here you usually do quick iterations of prototypes, you learn, you try to make product solution fit and product market fit. And yeah, here already on this cycle, we can cooperate because usually we are well equipped with prototyping equipment. We have machinery, testing facilities and stuff like that. And even more important is when we come to this scaling up phase. Here I would say probably 99% of ideas face with very big difficulties in scale-up phase. And this is something where also cooperation between companies and I would say startups comes in hand. Because if you see classical development of products, as it's shown on the picture on the right, I would say this initial phase, it's covered in this area, which is marked by a blue circle. So from pre-development to confirmation and first functional prototypes. This is like, I would say this is a classical path to innovation. Companies have then different names, have several milestones between those phases, but in general, it goes like this. And samples A are usually mock-ups, are functional prototypes, but done with, I don't know, milling, printing, let's say universal technologies for rapid prototyping, which you confirm the functionality. And this, I would say, for example, if you are coming at this stage to the company, perhaps the most convincing evidence that your idea works is, I would say, functional prototype, not completely functional, not end design, but something that confirms your idea. Then on the next phase, B phase, it's usually when prototypes are done from prototype tools, from prototype technologies. Here, this stage, it's important because you come to the design freeze of the product or services. So it means it has been tested also with customers and that we all agree this is the end product that we want to have, that we want to launch on the market. This is important milestone because actually the huge costs are then started after this phase. When you start, for example, in our case, we start ordering serial production equipment, serial tools, and here the costs, they go rapidly up to several millions. And yeah, you want to be sure that you are doing the right thing, the right stuff. Also time-wise, this is usually, I would say, yeah, if there's one small design change usually takes how much to say at least 3 months that's everything validated and that you can release it. But if you are working on a new product, it will take 3 years. In automotive, most often even more, up to 5 years before product will come into the market. It really needs to be thoroughly tested. yeah, sometimes people are surprised how long does it take and what everything needs to be done. It's not only on the company side, it's also that you need to obtain all the certificates, all the approvals from the government bodies, and this usually it's measured in months or even years, not in days. And most capable to overcome this period are companies, because they are faced with this process quite frequently. If you are for the first time, this will be a very difficult period. But when you have established processes, when you have knowledge, when you have equipment, this goes then more naturally and more faster. Yeah, then on this area, you start with production. So this is start of the production. And yeah, at the end of the project, it's after a while when you get all the capacities on track, when you get all the quality issues solved, then you can finish with project and regular productions takes over. So this chart I wanted to show you how much additional activities are involved besides, let's say, first initial idea. It's really, I would say, initial idea, it's important, but if you see the complete picture, it's much less than 10% of the whole work involved that the product actually finds its way on to the market. And even there, coming from R&D, I usually say, okay, we are quite expensive. We use lots of funds. For example, for marketing, then later on, you usually need 3 times as much of resources in money, but than for the development. Usually even higher costs, and then later on. Yeah, this. If you would ask me where to enter, I would say somewhere in this blue circle area, till functional prototypes. This would be the best time to enter. But of course, what I'm saying, it's valid for our type of company, our type of products. It's not necessary that everywhere it's the same. In different environment, in different setup, different approach may be more optimal than the one that I'm showing. But to see the results of such approach, we have quite huge innovation rate. Sometimes we call it's too high. Around 30 to 40% of our products each year which have been sold are younger than 3 years. Normally, the innovation rate is around 25% of the sold products in 4 years. Usually, it's there are such figures, but this we are following because we then know that we are developing the right stuff. So it means they get sold on the market. And the other reason is that we make our product, that we keep our products competitive. Yeah, and perhaps the second thing that I would like to emphasize, although I'm coming from R&D, development of products, we are quite aware that also innovative technology is equally important because products you put on the market, and by our experiences, in 3 months you can get copies from competitors. They are quite quick with copying, but if you have technologies behind, special technologies, then this is the best protection for the product. That's why we also established development of technologies, which is a separate department to existing technology, which is responsible for implementation of new product. The department of technology development, actually, they are looking for the new ways, not existing ways, how we do some processes. Yeah, to be able to maintain all this, we invest each year around 11% of our turnover to new products, and yeah, up to 5% into the development from our turnover. Perhaps the overall strategy, if I simplify it, is that we usually tend to have less material than competitor does. This is direct impact on the cost side. We do aim to be in the premium segment of solutions. So this means that we, in our case, we usually strive to have the highest possible efficiencies. For example, for heat and ventilation, the motor drives together with control electronics, they have efficiencies more than 95%. And this is the reason why, for example, giants like Facebook, Google, they use our drives in data centers. Because every percentage where you have a wall with few hundred of ventilators there, that they keep cool the hot information that we send, every percentage means significant savings. Yeah, and also important is lower noise. This is what we hear, but this is also then connected to low level of vibration, to higher reliability. So if I would say what we put emphasis on are those three fields. More and more it's connected also to the IT world. Yeah, and perhaps the last slide that I wanted to mention, to have a good cooperation between different companies, institutes, faculties, or individuals, you need to have aligned values. So, for example, these are the values that we developed throughout our history. Like I said, we are located in a narrow valley, so I don't know, loyalty became one of values that we care much about, and we also do practice this. For example, with our customers, we cooperate with those which we have the longest cooperation. It's more than 50 years. So we strive to have a long cooperation with our customers as well as with our suppliers. So I would suggest for institutes, laboratories, if it is possible to have a long-term cooperation, so this is beneficial for you as well for us, because we know you know our products, you know the way we work. It's much more easy. And of course, on the end, we need to be focused on customers, on suppliers, as well as to our own employees. We need to be on the end profitable, to be able to be on the market on the long term. We need to be creative, ambitious, and perhaps also one of the, I would say, of the important aspects of cooperation is respect. You need to respect each other in a relationship. I would say sometimes you need to be humble. You need to listen what the opposite side is saying. You need to try to understand them and to find the solution which works for both sides. This is, I would say, for cooperation, probably the most important are social skills. All the rest we can establish, we can buy, outsource, but how we on the end cooperate and we do business, it depends from the people involved in cooperation. And yeah, with this I would conclude. I would thank you for your attention, and then later on I know there will be some questions, and hopefully also suggestions, comments, how we can even further improve our cooperation with institutes, faculties, and so on. Thank you.
Thank you very much, Yanis. Perhaps just a short question, because you said that you have a matrix of R&D departments, so it is not hierarchical, but there is a matrix, and each one or researchers could contact you or your co-workers on any level, but if they know them. But what do you think would be best way to approach you, your colleagues, if someone doesn't know you? So how could they then just get all the information about your strategic alignment, your challenges, for example, and then just try to contact you in order to convince them to start collaborating?
Yeah, the first information about what we do, what are our general directions, our general strategy, it's internet site, I would say. But then the next one, I would say email. For example, there we have a point of contacts. And yeah, if there is an agreement, then it should be followed by perhaps firstly internet connection like this, that we get first impression, and then later on visit and hopefully start of fruitful cooperation. The reason why I mentioned colleagues in the departments is because all our colleagues mainly came from different laboratories, from different faculties, and personal knowledge, it's usually the quickest way. Otherwise, we need to do this first contact. And this is what I said via email, then internet, telephone conferences. And on the end, it's always wise to have also direct personal contact, at least at the beginning of the project. It's usually good to meet in person as well.
So also industrial conferences and fairs, these are the types of events that would be appropriate also for making contacts internationally, not just nationally.
Yes, and also perhaps an important source of contact are also these European or state projects. We do cooperate with many faculties around the Europe through these subsidized projects, research projects, and sometimes they evolve into the long-term cooperation.
Okay, great. We will talk about more how to contact you or the experiences later on. Do we have another question from Simon? He would like to know, would a non-engineering research involved from the later stages of product development be also relevant to you? So what he means is marketing and interaction design and testing. Would that kind of cooperation be of your interest?
Yeah, it would be actually marketing. I would say if I go back to this lean product development cycle, here on this phase, this is something that we engineers usually neglect a bit, but we now more and more we are aware that it's usually better to do really a thorough research on marketing side before you start investing too much resources into the development, in detailed development. So yeah, such skills are important for us, as well as testing and also other things that are involved. For example, life cycle analysis and stuff like that. It's getting more and more important in initial phases.
Okay, great. We will get back to questions later on. So Yanis, thank you for now. And welcome. Now we will proceed to the other side. So Professor Andrei Kos, He is our colleague also from University of Ljubljana. He's head of laboratory for telecommunications. And this is one of the biggest, if not the biggest, laboratory at University of Ljubljana. He's also a researcher in the IT and digital field. He is the president of our innovation board, so he is the one who decides which innovations we are going to take over, commercialize. He is a powerful man that way at our university. And he's also a member of the European Universities Association Expert Group on Innovation, so EGINO. And since he obtained his PhD in 2003, he has been collaborating with many companies on various topics, both Slovenian and international. So Andrej, we kindly invite you to present the researcher's point of view on the collaboration with industry. The floor is yours.
Thank you. Really nice introduction. Can you hear me? And can you see my slides?
Yes and yes.
Thank you. So I've got 6 or 7 slides. Then we might talk about more during questions. So just to give you the idea, this slide is important because we'll talk about it later. So the country we come from is Slovenia. So you see it on the map, 2 million population, and some things we do very, very globally, and some not. So I come from the University of Ljubljana, and University of Ljubljana is a pretty big one, and it has 27 members, faculties, school, colleges, so on. And I work at one of the member faculties, and this is Faculty of Electrical Engineering. So this is this slide. So the Faculty of Electrical Engineering, we have around 300 staff, academic and research. Now there are very different faculties in terms of what you do as a faculty. So some faculties do just teaching, and some faculties do teaching and a lot of research. So in our case, Faculty of Electrical Engineering, as said, 300 staff, and we have approximately half the budget. So okay, 2,000 students, but we get 50% of our total budget. It's for teaching, so it comes from the more or less national budget. And the other half of the faculty budget comes from the research. And out of this 50%, the 40% is European and national research projects, and the 10% is direct industry cooperation. So this is, if you add this together, you get 50. So on the university level, I deal with the technology transfer office and so on. But on the lab office, this is what I would like to talk today about, is I'm the head of the laboratory for telecommunications. That's one of, let's say, 30 labs at our faculty. And our team is 40 people plus 20, let's say, students, but they work full-time or half-time, let's say. So a big team. And for our team, we have the teaching budget is 25% of the staff in our lab, including myself. I count myself as teaching, although I do a lot of, let's say, research and development as well. And the research and development is 75% of the lab budget. And if we divide this 75%, this is what we are interested in today, is we have from 75, we have 30% is direct industry cooperation. That means direct contracts with industry. And 45% is European and national research projects. So all these down here, we say it's gained on the market, but still, you got the idea what's the percentage of research and development. So these two words, I think, are important. I'll come back to later. So currently for the discussion here, it's not so important, I think, but I'll tell you what we do. Basically, it's Internet of Things, cybersecurity, also multimedia. So this kind of stuff is what we do. So ICT, cyber, Internet of Things. Now, if you want to have this team, let's say, financed and do the research and do the development, there's a lot work to be done. So it's very, very different to just doing the teaching or just doing the, let's say, this basic research. So because we are structured a bit differently than, let's say, the average lab, and we are structured because we do a lot of cooperation with industry and a lot of research cooperation, our goals are excellent education, of course, for the students. That's the basics. And then also the cutting edge research. That means that we research what's on the edge. And of course, it's important that the research projects are cool, because the team has to be there, motivated, and be there, not going just somewhere else because there's a big pool of talents out of the faculties, even when students finish. And we say cooperation and knowledge transfer has to go in both directions. That means project cooperation and also student cooperation, because sometimes the companies see the cooperation or research cooperation just in terms, please send us some students and we are happy. So it doesn't go like that. And of course, international component is very important for a team like this. Just to give you the idea, blue is a non-industry financing, and red is the industry financing. So you see that around one third is red. Sorry, red is the industry, and 2/3 are blue. And blue means teaching, national research project, and European research projects as well. So everything that's budget money is this, and everything what is industry money is red. So I prepared this slide just for this presentation. So how it is? So you will remember this slide later. So I tried to get out of our system the data for last year, how many projects we've got. So these are the projects that were running in 2022, and the projects are in the size of euros per year. And these are different projects, and I've hidden what kind of projects these are, but the red ones are direct industry cooperation, and the blue ones are different research projects, European or national. So that you get the idea, what does it mean to collaborate with the industry? It's a lot of projects, and the projects are not very big ones. So you see, it's a lot of effort for the team to handle this. We are not happy. We are happy with the amount, and we are happy with the cooperation with companies, but we are not happy with the sheer number of, let's say, contracts or number of interactions that we have. It's a huge burden in addition to do the teaching. So this is the second last slide. I've got another one, and I'll show it later. And these are the topics you would be interested in now, I guess. So how to start the cooperation? We've got different options. Sometimes we go on a research project together. We do not know all the companies in there, and then after the research project is going on, the subsidized normally, we see each other and we say, okay, let's try direct cooperation. That's one way. The other one is mouth to mouth. So one company says they were cool. They do this and this. Try this. They do cybersecurity very well. Do that. Ex-students. Many projects come out of training. We do training for companies. So one of the projects is also training, conference and web, but this is not so much. The question is whether to start cooperation on a personal level or an institutional level. So many times we have visits from companies to our faculty, and there's 10 people on one side, 10 people on the other side, and then we talk what we could cooperate, we present and they present and so on. But actually at the end, you have to have a sponsor in the company. That means you have to get involved personally in order to really start cooperation. So it's both at the end, but without persons or people trusting each other, it would be hard. Without trust, it's a research project, direct. Many times there's trust among people. So the question is small project, big projects. Normally the research funded by European Union or national is much bigger project than research funded by companies. Okay, we've talked about quality of cooperation a bit, but for the long term, this is important. Knowing each other and quality of cooperation, and some cooperations gradually grow, and I would say that 1 out of 10 cooperations that you start then gradually grows for, I don't know, 5-10 years, each year a bit more. So it's a lot of effort to start cooperating, and it's a lot of let's say KPIs that have to be yes that you get a long-term cooperation. We will talk at the end with the questions probably also about this content, legal, time, knowing each other. Of course, first you have to make a contact or join on the technical level, and then all the legal stuff comes in, like non-disclosure agreements and contracts and all that, and this can take time, and sometimes it's like, let's do this very quickly, and then you wait for the NDA or for the contracts for 3 months, and then okay, we had to wait, but now please do it in 1 month. So we see a lot of that. I know that these are just the starting points for the questions, but the time I have is pretty limited. And then research and development. I very like to see this or to tell you this difference between real research, or let's say basic research, versus development. As you saw on the map, Slovenia is a rather small country, and in order to have like the basic research and paid the research for the team that would be for a bigger company, you should have a big company, and you should be a world leader, and then in this case you can do the research. We have only a few companies in Slovenia that are big companies that are able to do research and pay a research group to help them develop. We have some big companies that are followers, but they don't really need the research, they more need development. So research and development, I see this, you can combine this in one go, but many times I could say this is research, this is development. And with many companies, this R&D is actually development, not the research. And in Slovenia, we also have a lot of small companies that are very good. They're actually world leaders doing very focused projects for different areas. However, in this case, the research is very focused, and sometimes it's a bit harder to cover. If we go into, I'll explain. So in our case, the financing of real research is still European and national project, and the financing of more development with the bits of research goes into the cooperation with companies. And of course, then we have the topics of technology maturity, proof of concepts, deadlines, when you're going to do it, what's the deadline for the company, what's the deadline for you, how do you feel it, do you understand time, money, or you just understand, I want to do my research and so on. This is a lot of topics to talk to, and I would be happy to do that in the questions area. And there I've got one more slide at the end. For the end, the ICT environment and innovation change, because with ICT we have to cover a lot of areas, and this is also an issue, how to do it. I will finish the PowerPoint for now, and then maybe a few questions now, and then later, probably for overall questions, I will get back to you.
Thank you very much, Andrei. Perhaps just one question is, from your point of view, how can you, or what is the best way or best practice? How can you persuade a company to invest into meetings with you and with to show the interest in your technology of your solutions? So do you just come there and present your article, or what kind of approach do you have towards the company?
Actually, you don't persuade a company to listen to you, because if they need persuasion, you probably won't get far. So some years ago, let's 5 or 10 years ago, it was conferences, seminars, and this, let's say, not the scientific articles, but the conferences or the seminars from the industry where we talked about, and when we did the links. Today, these links are done differently. Today, many companies come to faculties in search of young talents. And basically, many times the goal of the company is, can you help us find talents? We would like to employ 5, 10, 50, 100 engineers. And this is how it all starts. And then we add, training, and we also add our pilots, and we also add our proof of concepts. We also add our areas where we are good at. And this is where we start talking about the company's problems. And then it goes on and on and on. And then at the end, you start cooperation, maybe with a subsidized project, maybe with a small direct project. And sometimes it just doesn't go on, because the company says, okay, I need talents, I want to employ them, all the rest, it's not interesting for us. So it's currently these options are the most often ones. I hope I answered the questions.
Yes, for now, thank you very much. Before we really go then in the discussion with all of you also, I would like to invite my colleague Katja Crgol. She's a lawyer at our knowledge transfer office. And she provides legal assistance in the protection and exploitation of intellectual property. By education, of course, she is a lawyer with a state law exam and an exam for representative of models and brands, design and brands, so trademarks. And she will explain a little bit more about how to take care and manage the information, what are confidential information, what to tell the company at the first meeting and what not to. So Katja, the floor is yours.
Thank you very much, Simona, for presenting me. So today we are speaking about the cooperation between the university or research institution and industry. In my presentation, I will give you a few legal tips that you should have in mind regarding confidential information and other IP issues that can arise from such collaboration with industry. I just have a problem. Okay. So when you're speaking with a company about future collaboration, it may happen that you're disclosing or exchanging valuable information. Of course, this is necessary, and it might involve giving written or oral information in order to describe your own research. So what are you doing, revealing your know-how, the data that you have maybe in your laboratory, or even an invention that it's not protected yet. If you don't want that the company uses this information, which are valuable for you, as it wants, then you should sign a non-disclosure agreement. So a non-disclosure agreement enables you to share your unprotected knowledge and ideas with others in order to assess their interest in working with you, and it prohibits the other party, so for example the company, from using your knowledge, your idea, without your consent, and even to disclose it to others, for example, to third parties, to their affiliates, and so on. It is very important that you know that the NDA should be signed before any information is shared with the third parties, with the companies. So before you have any meetings or conversation with them. We have different types of NDAs. On one hand, there are NDAs where one party, which we call the disclosing party, discloses confidential information to another party, which we say the receiving party. On the other hand, we have mutual NDAs where 2 or even more parties, it can be also 5 parties, are disclosing information to each other. In the NDA, you should define the agreed purpose for which the other party can use your confidential information. I was too quick. And also define the duration of the NDA from, for example, a few months or even to 1 year or maybe 2 years. It is important that you know that the confidential obligation will last also after the NDA has terminated. For example, even after 3, 5, 7 years, you and the other party that signed the NDA will be obliged to maintain the disclosed information in confidence. You can find a lot of templates of NDAs on the internet. Also, our knowledge transfer office has a template on the website. It's in Slovene and in English, but you should seek professional assistance in drafting it, because it needs to be adapted to your specific case. And for this, I'm sure you can contact your technology transfer office or the legal department at your organization to check and prepare the NDA before you sign anything. And now about a few tips that I would give you for maintaining confidential information when speaking with companies. Well, I will say in this point, the most important thing is that you sign an NDA before disclosing the information. Then it's also very good to keep a record of what has been disclosed during any meetings, conversations, and so on. It's very good also to mark the information as confidential, so everyone can know, okay, we were talking about a lot of things, but let's say that this information that are marked are confidential and can be used only for the purpose that is defined in the NDA, and the other information are not confidential, and we can use them and build our business or research on it. And the last tip would be never disclose too much. So never disclose more information that it's necessary. So don't disclose anything in details, but focus on a description of benefits that it could bring this invention to the company. So why would they need them? And when you see that they are really willing to take your invention, for example, or collaborate with you, then you should go in more details. Sometimes when you are speaking with a company about future collaboration, it is necessary to give them also some materials that you own and can be valuable for you, and maybe also they are not protected. In this case, we have a material transfer agreement, which enables you to securely exchange materials, for example, cells, antibodies, and so on, whatever, in order to estimate the interest in collaboration and test these materials. The MTA defines for which purposes can the recipient of the materials, for example, the company, use these materials. It has also some confidentiality provisions and defines the ownership regarding new potential IP that can be created. For example, if you send some materials to the company and they improve your materials, they make some improvement, in the MTA, it is defined who's the owner of this improvement, which is really important. You can find also some MTAs on internet, but it's really important that also here you adapt the contract to your specific case, to your needs. So you should seek professional advice also here, for example, at the TTO or legal department, or maybe external advice. The last thing that I will talk about is when you agree with a company about some type of collaboration. It can be a service contract, it can be joint research, it can also be that only you go in their labs of the company, or they give you their products and you are doing something on this. Well, here it's important that you agree with your partner on some essential IP issues regarding future collaboration. And I think that the best way is that you sign a contract in which you define your IP principles, so these issues that you have agreed on before you start to work together. In this contract, you should define the purpose of your collaboration. Then you should define the background that each party has and will be used in your collaboration. So if the research organization has a patent, a lot of know-how, and so on, or maybe the company already has a lot of knowledge, patents, what is everyone bringing to the project? And then you should define the foreground, so the results that you want to achieve and who will be the owner of them. So if you will do a new invention, a new technology, anything, then you should also define who will be the owner. This perhaps it's also important who is paying for this. And then the owner is probably the one who's paying, but it's not always the case. If you will agree that you will be joint owners, so that everyone has created this new invention, this new technology, then you should sign afterwards a joint ownership agreement that will define more in details the use of the invention afterwards. Another important issue, I think it's also the most important for researchers, is publication. And you should agree also about this with your industrial partner. And it's better if you do it in advance before you start to work together, that it's clear how you can publish the research results and which are the limitations. So here I finished my short presentation. Here are my details. If anyone would need any advice, can freely contact me. Thank you very much for your attention.
And thank you also, Katja. So from the list of questions that we have received prior to during your registration process, there is a quite renowned question that is still perhaps not, the answer is still not known. So it is as follows. Is it possible to publish the results of academia-industry cooperation, despite the mismatch of the open science principles and also the goals of commercialization of commercial entities, so protecting the know-how and IP? So for all three of you. So perhaps if Katya, you start, what would be the best possible solution to fulfill all three? So the publishing of the article, taking care of open science, and also taking care of protection of IP.
Okay, thank you, Simona, for this question. Well, it's usual that the researcher would like to publish everything about their research, what they're doing. On the other hand, the companies just won't keep it secret because it's best for them. And now, how to meet the interest? Well, few tips that I would give is that you should agree on certain periods during which publication will be possible. So you say, okay, the publication will be possible, but first the company will have to review the publication. If the company sees that there are some confidential information in the publication that you want to make, allow them to remove some of the information so they will be more secure. And on the other side, also, if they want to patent something, but also if you're not doing research, collaborating with a company, if you are just made something that could be patented, you should first fill a patent application, and then you can publish it. So here are my short tips that of course you have to agree with them, but you can find a solution to this.
Okay, thank you. Janez, I suppose you have practices in that kinds of joint ownership, perhaps of IP, or even joint articles. So how do you approach this matter?
Yeah, I don't see this matter so problematic. We do have lots of cooperation with, for example, young students that they are doing their PhDs, and to be able to do PhD, they need to publish articles. And I cannot remember there would be a time that we could not agree on what to publish or what not to publish. We always found a solution. And I think this understanding between industry and academia grew in recent years, because lots of heads of my departments, they are PhDs themselves. They know what are the issues behind. They know what they need to enable their partners which are working in academia to have their goals achieved as well, not only for the companies. And yeah, we usually do agree. And also internally, of course, we discover new things that we patent. And usually there are guys which are innovators, which are researchers, to say so. And they found this new knowledge, and they are, let's say, they have moral rights. Of course, material right, it's owned by a company, but we don't see an issue with this.
Okay. And Andrea, I know that you are working in technologies that are rarely patented. Still, there is a lot of IP behind your work. So how do you manage your, perhaps, articles and IP and open science?
Maybe for the cooperation with companies, actually there are three different cases. One case is a subsidized project that you do some research together. In that case, there are templates, and normally is that whatever you do, it's yours, and for the time of project or for the duration of the project, all the partners can use your IP, but afterwards, not like afterwards, some contracts have to be done. This is one extreme. The other extreme is that there is a direct contract with the industry where the industry knows what the industry wants, and they come to us and they say, we would like this and this and this. Could you please help us research or develop that? In this case, it's clear case as well. The IP belongs to the company that ordered it, and basically takes everything. the complicated part is when, for example, we have a working prototype or we have an IP that is ours, and it's basically from the article, from the research, from anyway how we come to it, doesn't matter. And then you show it to the company, and the company is excited about it, and the company says, yeah, we would like to have it. And then the real hard process starts when you would like to sell it or give it, not give it, sell it to the company, but then to draw a line. Where is the previous knowledge? What about if we upgrade our proof of concept, that it becomes then it becomes more usable or useful for the company? Is it then exclusive? Is it non-exclusive? How does it go? Where do we draw a line? What's ours? What's common? And so on. And this is the hard part, because we think we've done most of the things, and it's just the adaptation. And the company says, no, this is just you did a prototype, but actually all what I will tell you from now on, it is ours. So basically this is more than what you have done before. So we draw the line somewhere else than where you would like to see it. So in these cases, the negotiations are much, let's say, harder. But what we see is that very, very big companies basically have an issue with that, and very, very small companies have an issue with that. And the companies that are in our case the middle size, it's much easier to discuss with them. So the small ones and the very big ones, we talk a lot about IP, and the middle ones are, let's say, we agree easier. So yeah, in short.
Okay, thank you very much. If we return to the beginning, perhaps, or the first question to you, Yanis, why would industry be interested in collaboration with academia? I know you talked a lot about it, but still, what can universities bring the added value to you?
Yeah, first of all, it's being how to find the right word, that you know that you cannot do it everything by yourself. This is something that I think most of the people working in industry, we do know this. It's just too many specialists that you need, and there is not possible for one guy to be master of all trades. This perhaps a few years ago was still the case. I remember an example of one of our heads of some applicative R&D. He didn't want to collaborate with external partners at all. He knew everything by himself, but he was quite skillful, quite knowledgeable, but there was not a breakthrough solutions. That business unit didn't grow, and it took us I would say several years that we overcame this way of thinking. And yeah, okay, he retired in between, but now this business unit is growing quickly because they are open for collaboration with faculties, with also industry, external industry partners. So yeah, because one guy cannot know everything, this is a must for us to cooperate.
And what is expected from universities when you start collaborating with them?
Yeah, I think to know what to expect from the universities, it's an initial and crucial item, because not every project is appropriate for let's say universities. Usually it needs to be, I would say, publishable. This is something often a must to have interest at university. Then usually should not be under time constraints. There should be, I would say, state-of-the-art research behind the issues. Those are items that are then probably attractive for partners at universities. And we do have such challenges, only that we need to know how we allocate those challenges. And to address, of course, also the right partners at university side or institutes or other, let's say, hubs of science.
And for both of you, Andrei and Yanis, how to facilitate the alignment of academic offer and industry requirements? From your experiences, who would like to go first? So how to, this is about expectations, really how to align those, what universities can offer and what companies require.
Maybe I can start. Sure, I'll be short. So I think the most important thing is that you talk, that there's a two-way knowledge transfer. Mm-hmm. So that means that at the university, for example, in our area, in our field, the ICTs, so many things going on that we no way that we can cover everything. And talking to partners in industry, I think that's, and on a very regular basis, not every year or every 2 years, when a company would need this and this, and they would come and say, oh, we would really like this, could you help us? This is far too late. It's, I would say, talking on a institutional level once or twice a year is okay, but talking on a personal level with different researchers, it has to be monthly in order to have the contact, knowing what the company does, for the company knowing what's going on in the university, where are the strength points, where are the strong points, where not, and so on. Because currently it's so much things that you simply cannot cover everything. And who does what, who's good for this, who's good for that, that's you should know it. Even for us, we have to know the companies, what companies need what kind of services from us. Some need just training, some companies need real research, and some companies need just the basic things just to start the area of research inside the company and so on. So I would say talk, discuss, communicate, and have a personal relationships with many people in the company, not just on high level.
Thank you, Andrei. Yanis?
Yeah, I would agree. The trust between the partners, it's a base on which you can build on. If there is no trust before, you need to be as transparent as possible. For example, when we collaborate with young, I would say, startups, usually I would say they overestimate their contribution, and I do understand why is this, because they don't have experience what's everything behind, still needed that some product comes to the light. That's why I always say, let's do it everything as transparent as possible. We do it the same way as with industrial projects, when you need to make every evidence to your industrial partners, which also on the end they pay for the research that you do, for the development that you do. And the same way it's also, I would say, with, if you don't know the partner at university, it's the best way that everything is transparent all the time, and then you can agree, okay, you invested so much time, you invested so much resources, and the opposite side the same, and it's quite easy then to evaluate the contribution. But if you know somebody for a long period of time, you collaborated on many projects, then you both, all partners both know and trust, then it's much more easy. That's why I'm similar as with our customers and suppliers. I always suggest to have long-term cooperation. And sometimes it's slightly more beneficial for one side, and the next time it's slightly more beneficial for the other side. This is something normal.
Okay. There is also a question that perhaps is shows a bit of thinking. Yeah, how to approach someone who you don't know. So a new company. And it goes like that: how to make your partnership offer attractive to the company, and then of course what would be persuading you, Yanis, to perhaps start collaborating or just talking to a totally new, unknown researcher? And what would be then expected from him or her, so that you would be intrigued? So it is a question not of long-term relationships, but perhaps on how to start this relationship and how to make myself or researchers himself interesting.
Yeah. I will.
I
would suggest that you make a.
You froze a little bit. Could you repeat it, please?
Yeah, I would suggest to do first some research about the strategies, about the need of the partner you wish to contact. And because if you come to the partner at the right timing and you know what are the issues that he or she has, then he will be, let's say, more willing to listen. You must know that probably on industry side and as well as at university side, people are quite busy and they don't have time just to listen. But if you address the right issues that are troubling him or her at the right time, then it's much more likely that he will take time and listen to you and invite you. And as also Andrei mentioned, if he or she approaches you, this is also a good start. So it means that he already knows he has an issue and he knows that you can solve it. This is also a good starting point.
Thank you very much. So for both of you again, Andrei and Yanis, in your opinions, what are the major hurdles, so obstacles for collaboration from your perspectives? So Yanis, what are the obstacles, for example, from your university side? And Andrei, in your opinion, what are the obstacles from that you see from industry side? So a little bit twist on it. Who would like to go first?
Perhaps Andrei.
I can start. I think the first big obstacle I see is that the companies many times just come to university or to faculty and say, we need this amount of people, engineers to employ, and then the next level, let's start cooperation, is it's not a straightforward one. And maybe this is the first one. The second one is maybe the alignment, what the research part or development part would like to do or is capable of, and what are the real needs of the company. This sometimes we explain something that the company doesn't need, or the company comes and would like something we cannot deliver. So this how to say, the leveling of needs and abilities to execute. This is important, for example. And yes, to start the real cooperation, there is trust. So you have to have also on both sides people that understand a bit different culture. So, for example, we are a big lab, and actually we know that we have people that are excellent researchers, but sometimes they forget about deadlines. And we have a very good, let's say, people that do more development, and they are excellent with deadlines and what to do, but they are not so good in the innovative world. So, and I think on the company side, sometimes is like we would like to have this and this for these deadlines and so on, and sometimes they would just need, please, we have a huge problem. Our partner needs this and this. Can you help us find a new solution, a totally new solution for this and this? And these are very, very different tasks, and the company and the faculty have to be aligned what is needed and what can be delivered and with who it could be delivered, so that you don't get different. So you have to know the people on your side and know the people on the other side as well. So maybe, and there's much more.
Yeah. I can again agree with what has been said. Perhaps I would add that, in companies, usually when there are, let's say, persons coming from universities and they did their PhDs, they know already what can be expected from, let's say, research done on the university. And this is important because not, as already mentioned, not each problem, each project, it's appropriate for the, let's say, university environment. So yeah, companies need to be aware what can they expect, and opposite. Sometimes I have an impression that companies are treated as I say some sort of charities. You must be aware also that companies they struggle for every cent, every dime. You have long and really hard negotiations with partners, and you need to also respect this side of a coin, and that you need to be realistic about your contribution. And if both sides can come to the common understanding, common agreement, then I don't see a big hurdle to cooperate between industry and universities.
Communication and long-term, longer term, at least, willingness for collaboration then.
Yeah.
Great. Then we have another question for Andrei. It is based by Simona, not me. Question: are masters and PhD students involved in your projects in collaboration with industry? And if yes, on one hand, how do you attract them? And on the other hand, how do you prevent to be hired by companies?
Very good question. Thank you. Yes, or yes and no. It depends depends on what the students would like, or the student would like, and what is the way of working. So, like, if we have a contract with a company and we would like to cooperate with the student, we first need half a year, 1 year of cooperation with students in order to be able to let's say rely on the work of the students for the industry project with the contract. It's not easy if you have to do this with the deadline and even with the guarantees and so on. So the answer is yes, but not everybody. You have to know the students very well, and it's got to be fit. And this is a longer process than you might think. This goes for direct industry cooperation. Of course, students for the project that are meant for students, we involve them straightforward, very easily, no time, like in no time. But for this industry cooperation, where the industry has expectations beyond just do something, we have to filter, and this takes time. Now the question is, how do you prevent to be hired by companies? Actually, this is a very tricky question, because actually we are here for the good students to go to the companies so the companies can prosper. On the other hand, there's so many things and so many new things that we need young talents to think the other way. Basically, we need students to develop ourselves as well. So what we do is, actually, we do not prevent students to go to the company. So anybody can go. So we cannot say no. But if you remember on my slides, I had some word cool projects. What we try to do is do projects, let's say, that might not be so cool, to combine with the projects that are really cool, so that we normally the best students that we have, they have two kinds of projects. The projects that are also for the companies, that might not be the top-notch research, because it doesn't always go like that. And we combine that with the best research that we could get. We might get it financed from the European project or somewhere else. And we combine that so that the whole package for the students, it's cool. So that might, I hope it answered. And we tell the students that they will learn a lot here, and they will have cool projects. However, we know that the company always can offer much more than we offer. So we have them with the cool project and with the projects, and there will be a lot to learn.
Julia would like to know what do you mean by cool projects? Can you have one example? Can you give one example, perhaps?
The projects that are up to date, so that are the projects that are actual now, the project that the students are motivated to do. That means if a student says, I would like to do this and this, it has to be something from what the students would like to do. And many times it's also the team behind. So students, there's a lot of students that would like to be involved, that would like to work on a project, but alone they will not manage. So many times we see students that they ask, who will help me? Is there a team of 1 or 2 people that will help me, that we will do it together, and so on? So many different things add to the project being cool. But actually, this is a very this is a thing that one cool project cannot be cool for the other one, but the project has to be cool so that you are still motivated to work on the project, not for the sake of euros, but for the sake, I will learn something new, I like it, I'm motivated to do it. It's and I would do it on a ethic, not the I will do it because I would like to work on this topic. So this is
okay. Thank you, Andrei. We have another question regarding the industrial PhDs, and this is for Janez. Of course, a lot of, or all of universities can offer trainings for PhDs, industrial PhDs, but the question is, how can we convince companies to fund the employees to embark on a one PhD training? So why do you send your employees to take on further education and training also?
Mm-hmm. Yeah, of course, it's perhaps most significant. It's a good experience that companies, usually the companies that send their employees to PhDs, they already know what they can expect from such well-educated future co-workers, or even co-workers. They do PhD within employment at the company. In our case, this was situation that we saw that we can only go ahead, we can grow, or we can be competitive only if we have the latest knowledge, latest findings, and that we also develop this knowledge further on. And that's why in Slovenia, it was a really good period after 2000 to 2009, when government supported PhDs in industry. And a lot of our industry at that time fulfilled their R&D departments with PhD guys or girls. And after the crisis, this program was banished. So I know quite few companies that they continued with education of their employees on the PhD level, because they had this very good experience with what they bring to the company. And yeah, also through those girls, which had PhD, also collaboration with university then grew to the next level. It was more equal level, it was more dynamic level, that both sides then benefit. For example, when you apply for a funded project, you usually need to have collaboration from several countries, from industry as well, from universities. And yeah, if you have people that do understand what is needed from each side, then this is much more easily, and on the end also the results are much better.
Thank you. And I have one last remaining question from the list, is how can we motivate companies to join and stay engaged in research projects? So, and this would also be for Andrei and Janez. For Janez, how do you stay engaged? So what is your motivation? I think that you talked a little bit, but in short. And then Andrei, how do you motivate the companies to stay connected with you?
Yeah, for companies, of course, if there are results, companies will be motivated to collaborate and to extend with collaboration.
Short and sweet. Thanks. And Andrei?
Yes, the long-term cooperation, it's, let's say, easy. You have to go on and on and on. And for the new ones, that's a lot of work. That's sometimes I say that I do two jobs. One is the teaching as a professor, and second one is the manager of a research lab. And these are two different jobs. You have to talk to many different people. You have to explain what you do and do the social networks and stuff like that. So being connected takes a lot of your time, and sometimes you don't have it. So it's yeah, it's hard because it takes your time. Lately in our area of work, it's a bit easier because many companies contact us for talents, for engineers they ask if we could cooperate in order to get the engineers, and then we start talks about research cooperation, PhD articles, what we do, and so on. And this is the easier start currently, but it is hard and it takes time and it takes work. It doesn't happen just because you did an article or because you did something or because you think that you are cool.
So why do you both do it if it's so hard? And this is this is the perhaps last question that I would implicate as some sort of advice on why is it worth it?
Because it's the right thing to do. I many times think what we do in addition to teaching all this, it's actually it doesn't add much it adds not very much to my professional career, being a professor formally. Informally, yes. Informally, everybody knows it, but formally it doesn't add much. But I do it because I think it's the only right thing that the technical companies or even the technical faculties cooperate with the industry, and that the tech transfer is both ways. It's what I think it's right, and I'm willing to add my time into it. Yeah.
Janez?
And from my side, perhaps the straightforward answer would be to be competitive, to remain competitive. It's the only way. And the second, perhaps also connected to coolness of the project. On the end, the things that you do have to have meaning. And if you can present also within the industry, for example, if we assume that we don't have cool projects, but if you then present them the higher meaning behind those projects, I think employees are willing to invest more than they would normally in regular working hours.
Well, thank you very much from my side. There's a few minutes left, so I would like to ask the audience, would anyone like to post any comments or have additional questions? Now is the time. Is there any additional questions, or we answered all? Well, I think that it was being quite a comprehensive discussion. I hope that it was useful to you. Of course, thank you very much to Janez, to Andrei, and to Katja for your contribution and the insight into your work. And for all others, the recordings will be available, and also the PowerPoints will be shared among you. And we will also like to ask you for the feedback on the workshop. This will be also sent to all of you afterwards, after the presentation, after the end of workshop. So thank you again very much to everyone for your patience and for your attention. And I wish you a very nice day.